now Madam Mila Mitra, our Director and come on the dais, please. Good morning, students. Good morning, students. As you are aware that we are observing National Day tomorrow. But if we wanted to remain more activity, we are also as a part of the National Space Day celebration. All of you are aware that everybody is celebrating National Space Day. Please tell me. Okay. Now wasting time is the request our director, please welcome address. Good morning, boys and girls, guardians, teachers, my team, the most important, Dr. Mila Mitra, who will be deliberating on the occasion as my colleague conveyed. This will be the kickstart for the National Space Day, which is celebrated every year. As you remember, 23rd of August 2023, India successfully landed the Chandrayaan capsule. What was the name? Lander. What was the name of the lander? Vikram. Vikram was landed safely this particular day. And Pragyan rover was so in order to celebrate this occasion, the government of India decided to celebrate with the students, young kids who are the future for space program as well as other different streams, science and technology. You are the future. You are great country for further greater heights. So this year, what is the theme of this particular National Space Day? Any idea? As you know, we have got great traditions in astronomy, and of course nowadays after landing on moon, we are the fourth country in the world successfully landed. We have got bright future, very illustrious past. In past we have had some of the best astronomers in the name of for example Aryabhatta, Brahmagupta, and the line is long. In order to honor the past history of astronomy of India, and at the same time celebrate what we have achieved and what we are going to achieve in terms of the space program for India. This year theme is bridging the past and future in context to the astronomy, and that is why we have come up with one exhibition. I hope this exhibition is and it will be formally inaugurated tomorrow. Some of you can come and the theme of this exhibition is exactly this, related to the astronomy, past and the achievement of India as well as the space programs are concerned. So with this theme in mind, will be hosting lots of programs for the school students, in the form of quiz, in the form of lectures, in the form of exhibition as I already told you. And many more programs are there which will be conducted during coming week. And I personally feel that your visit particular to the National Science Center will be fruitful, and it will come to your expectation. And my colleagues and my team will be taking well care of all of you as meeting the expectation, visiting the science center is concerned. So without taking much of your valuable time, enjoying the interaction with Dr. Mitra, and I once again extend warm welcome. Wish that you will keep on coming National Science Center, because we conduct throughout the year programs on different occasions. You are into the mailing list of National Science Center. That's why you received this invitation. I'll request particular teachers to ensure that the student visits this particular science center. Now I'll request Shreya Kapoor is around. Big round of applause for Shreya Kapoor. From which school? Frank Anthony. Will you please welcome our guest? Thank you, Shreya. Now I'll request my colleagues to further continue this particular program. Thanks for coming. Hope this particular lecture and interaction with Mitra immensely inspiring. Thanks, Mr.
Thank you very much, sir. May I now request Shri M. Ansari, curator, to give a brief introduction of our today's lecturer, Dr. Mila.
Good morning, everyone. It is a great pleasure for me to introduce our speaker today, Dr. Mila Mitra. Dr. Mitra is the co-founder and academic innovative educational STEM and space that aims to foster interest in STEM education, the exciting domain of space. Dr. Mitra received a PhD in astronomy from Rice University, Houston. She is an astrophysicist who has worked for more than 20 years at NASA, Goddard, and NASA Ames on various satellite missions. She is privileged to have worked already with the ground explorer project at NASA, which is connected to 2006 Nobel Prize. Two of the course received the Nobel Prize in Physics 2006 for their work on the project. Dr. Mitra has been invited as a speaker at conferences World Astronomy and conference in Brazil, Global Hands-on Universe OSPAR in Europe. She has recently been awarded Rice University. In India, she has been as a science communicator and coordinator for International Asteroid Search Campaign, Asteroid Day, and Global Astronomy Month. She frequently appears on TV as a expert and contributes articles to media. Dr. Mitra promotes wisdom as a career and in the community. She believes strongly in young students and mentors in citizen science projects. With this brief introduction, may I request Dr. Mitra to deliver a talk on the topic from the moon to Mars, space saga. Thank you.
Hello everyone. I welcome all of you young science and I hope you're all excited about National Space Day. So thank you again to Director Sir, Shri Sharma, thank you, Shri Ansari, and thank you to National Science Center for inviting to interact with students. So today I'm going to talk about how we reached where we are here today. We are here today celebrating National Space Day tomorrow. And what are we celebrating for National Space Day? Thank you. Please shout out again. What are we celebrating? Landing of Chandrayaan 3. So let's go through how ISRO started. Where we are today. We talking about Chandrayaan 3. We will go on to future technology. Okay. So let me ask you this. If I ask any of you, do you want to go out with me and observe the sky? Who will be interested? Many of you. I mean, usually even I have this impression of astronomer that's really cool. If I say I'm a physicist, which I am also, people don't think it's so cool. So astronomy fascinates everyone. From ancient time, people have been looking at the sky, and using it for navigation, agriculture, for seasons. Astronomy is all around you. So we, as educators that National Science Museum, that's their goal. Astronomy is perfect for addressing all kinds of STEM, because it's all STEM, chemistry, biology, geography, computers, engineering, and also nature's lab. We don't have a lab, but sit in the labs and be students and go outside and what are the phases of the moon? Why does it change? What is an eclipse? You can observe and find the answers. No, astronomy and science, and have had a lot of benefits to science. We've understood our place in the world. What is our solar system? Where are we in the universe? Also, I'm going to touch on this. You may not realize that many applications we have now direct result space exploration. Space exploration has also boosted the economy. And again, I'm going to touch this at the end. But there are because of space, new technology, new industry. Now even in India, there are private companies and startups. So there's a big boost to the space economy. And new career paths have been created. Why does space exploration matter? Does it matter? Now, if I ask you this question, yes, it matters. But 20 years back, people used to say, should we really put in money going to space? When there's so many problems here on Earth. So let's understand reasons why it matters. Okay, so again, the big questions of where are we? Well, how did our universe form? Why do we know only life here on Earth? All these are philosophical questions may not know the answers, but we have trying to get the answers, and we do have some of these answers now. Space exploration drives discovery. For example, Chandrayaan found signs of water on the moon. Based on that, there have been other missions looking for water, searching for life. Anybody knows what is exoplanet? Anybody raise your hand? Yeah. That's right. So planets outside our solar system are in their own solar system. Their own sun. Are they habitable? So there's many exoplanets have been found. Now future resources. We know resources are getting depleted. Someday we may need planet. We may need more materials, possible habitats. Future resources. That is one of the reasons that are driving space exploration. It also inspires creativity. So many of you have been songs about the moon. So many even in movies on chart. It fuels creativity. There's so many paintings now. So people are greatly inspired by space. Now here's a term called spin-offs. Everybody knows what is spin-off. I've given the answer. But anybody wants to contribute a line? Okay, so let me tell you more about this. 20 years back, when I got my PhD, before that, people would ask, can we go to a taxi driver and explain why it's necessary to put something into space research? At that time it was hard to explain. But now it's not so hard. All of you have cell phones. That's the you can see directly. Science communication, mapping, satellites provided us daily. Now it's our daily need to communicate, live stream. Everything is through the internet and through satellites. So let's see some other interesting things you may not realize from space research. Okay, so here's one. Can anybody tell me what is the telescope on the left? Anybody shout it out? Yeah, James Webb Space Telescope. You may know the telescope started small, all the way and then moved on to larger observatory telescopes. And then there was space telescopes, because they don't have to deal with the atmosphere, and they can observe in different wavelengths. This is James Webb Space Telescope, really advanced optics and mirrors, huge mirror. As you can see, mirror is created out of joining sections, which are hexagonal. Now this optics has a lot of research going into it, and actually contributed to eye surgery techniques like laser. Now everybody knows large mirrors taken to space. How does it fit into a space vehicle? So that is the new thing. This is how new technology is derived. It was taken as an origami. It was folded and unfolded space. Went to space. So folding and unfolding is a new technology. And that's the way we get mirrors, bigger antennas, deploy them when they are in space. Now cell phone camera. We all say who has a better camera. I got a phone with a really good resolution. Speak about that. It came from the need of astronauts to take some kind of space that really high resolution, but it has to be really tiny because carry much weight into space. So these image sensors CMOS to cell phone cameras. Now same kind of reasoning. Apollo astronaut, they needed wireless communication devices led to wireless headphones. You know that in space, when you go to space, when astronauts have to helmets that are scratch resistant. Why? Because something might hit them. Pieces of particles, asteroids might hit them. That led to scratch resistant glasses. Similarly, if you go to the moon, who knows what is moon's gravity compared to Earth? Anybody can say, is it compared to Earth? That's right. All of you know this answer. Which on the moon, they bounce and they jump and they jump fun, but it actually makes it very difficult. So special rubber molding was, created to athletic shoes. You know, when space capsules come back to Earth, many of you watched Return. Many of you, it was quite a media axiom for return to Earth. It was quite a thrilling moment to the atmosphere. Because the heat is very high. So here, it looks like it's on fire. This heat-resistant material has astronaut suits and firefighter equipment. Okay, so that was space spin-offs. And now how did space exploration even start? It started in 1957. As you know, there was a Cold War. It was called the space race between USSR and NASA in the USSR and USA. And the objective was to reach space and to reach the moon. So that's what triggered space exploration. And here we have Sputnik, which was tiny satellite, almost the size of a football, metal antenna with antennas. Okay, next, I'm just giving a few milestones. 1962, ISRO started, there was another entity before ISRO, and then I'm going to talk more about ISRO. 1969, Apollo 11, that was a big moment because Apollo 11 reached the moon, and the first astronaut walked on the moon. 1998, the International was formed, and that's like a giant space lab. Many countries collaborate. Okay, so now I'm going to talk a little bit about this. Who knows what the name ISRO stands for? That's right. Everybody knows the year it was started.
90s.
Okay, so let's find out. Okay, so those who have just joined, I'm going to talk about space industry and where we are headed exploration throughout the world. Okay, so before 1969, it was not called ISRO, it was called COSPA, and that started from a small location in Kerala. Rocket parts were taken in bicycles, as you may have seen pictures. In 1969, ISRO was officially started. In 1979, the first satellite was launched. Aryabhatta. And this year we also had the 50th Aryabhatta launch. Now Aryabhatta was India's first satellite. It was not by India. The rocket launch belonged to the Soviet Union. In 1980, so India started developing vehicles, very small payloads, higher orbits. In 1980, the first SLV-3 was launched, which made India's first satellite launch. And then we have PSLV, then GSLV, LVM, and now ISRO sends its own satellites of other countries. Okay, here's another milestone. One mission in 2008 was India's first mission to the moon, and in 2013, the Mangalyaan orbiter mission, which made India the first country to reach Mars orbit, maiden attempt. Okay, I'm just going through this quickly. India has also launched a lot of satellite technology, launch vehicles. Satellite technology is also very advanced. Series started the satellite communications. IRS are sensing satellites. EduSat was very important. Remember that ISRO was space development. Why does it have to also help the country lead to developments that the country develop? And EduSat opened learning and virtual education. Cartosat was for 3D mapping. IRNS regional navigation satellite, and which provide a lot of information about the regions close to India. Now, space exploration, you know, some big things happened in recent years. By ISRO, Chandrayaan 1, Chandrayaan 1, 2, 3. I'm going to talk more about Chandrayaan. Mangalyaan was India's first attempt for interplanetary mission. And as you know, this made India's name big because it was able to do low cost, missions. This was being joking to the moon, following the moon, interstellar and gravity. Anybody knows how ISRO is able to keep its budget so low? Anybody can contribute one to that? Okay, so this might be beyond your scope. So let me tell you, India has this strategy, which include Mangalyaan strategy. India might have to reach very fast. It could use gravity as to go, take more time and reach. India also has a very focused approach. All the technology done, not just the time, not just the vehicles, but also the communications, the antennas, overall the project, everything needed indigenously developed, became something that India owned all the technologies. Now, AstroSat first was the first satellite brought in astronomy data. And then there was Aditya, which was India's solar space observatory. Now everybody knows why it was called L1 stand for. That's great answer. Lagrangian point. And there are other Lagrangian points. Everybody knows what is a Lagrangian point. What's the benefit of L1? Okay, so L1 is a point between the sun and the earth, in the straight line connecting the sun and the earth. It's somewhere there. It's never blocked the earth, nor is it blocked by the moon. It never experiences eclipses. It has continuous of the sun, and it also stays very stable in that position. So with that, I'm going to bring us to Chandrayaan. I'm going to talk a little bit about Chandrayaan. What we are celebrating today. India's journey to the moon. As you know, Chandrayaan means Chandra and vehicle. Okay, first Chandrayaan 1 launched in 2008. Anybody knows what Chandrayaan 1 discovered? That was very important. Water on the moon. How did it discover it? There was an instrument. Anybody knows about that instrument? Okay, interesting thing. Chandrayaan had an orbiter which goes around the moon. And it had what is called an impactor. What is an impactor? Exactly what it sounds like. Comes out of the orbiter and crash lands on the moon. As it crash lands, it takes observations and sends it back. So the orbiter is a spacecraft designed to without landing. Even some of the missions that have gone to Jupiter, or they have been orbiters because that's easiest technology. Landing is a lot more difficult. Okay, so the moon impactor probe just something on the South Pole. Okay, and it discovered in the form of water molecules on the moon. This led to Chandrayaan, which was India's second mission to the moon. Because there were signs of water, you have to follow up. Any day you are thinking of habitability on the moon, on Mars. One of the primary things is astronauts. What do they need? They need water. What else might they need? Anybody? They need atmosphere, oxygen, and they need the right kind of gravity. So we have to have a way to supply all of these. So Chandrayaan 2 was going to land at the south because that is where there's a possibility of as observed with Chandrayaan 1. Now here I have a map. It shows the polar area of the moon, and it shows that the majority of the missions till then landed not the polar area, equatorial area. Most of the missions near the equator. Why? Because the equatorial area has plain surface, not so much crater, it's not so shadowed, and now the northern south poles are shadowed. Why there are signs of water, but it also makes it dangerous to land. So south pole is where we were aiming for with Chandrayaan 2. And here the Chandrayaan 2 had three parts, the orbiter, Vikram lander, and the rover. So the orbiter was going to did successfully reach an orbit of 100 kilometers. It itself had some scientific payload, including a camera that was very powerful. And here I'm just showing you some snapshots of how tiny speck on the moon could be expanded and seen. Okay, so this is 5 meter crater. So this adds to the information that future missions know about and it can be used for landing or just to know about the moon. This was the lander Vikram. It was designed to descend and come out. The rover program inside the lander. So as you might know, the Chandrayaan 2 mission. At the end, do a soft landing. A soft landing is very hard. Because if you think an orbiter, a lander comes out at a horizontal of shooting a plane, even a paper plane comes out horizontal. At some point it has to become vertical and go downward. And it has to decrease its very fast, zero at the right time. At the end, that wasn't a problem. This led to direct learning for Chandrayaan 3. Okay, Chandrayaan 3 was in 2023 and launched at with the LVM 3 was even more powerful, a launch vehicle. And it did touch down on 23rd August, and that is what we celebrate. Okay, so the lander had legs. It had a bigger solar panel. It carried more fuel. It also had cameras where artificial intelligence was also at play. Because the cameras were determining exact area you were landing, changing its location slightly. So this is an example of artificial intelligence is used autonomously. The process that is being carried out by a space vehicle. Now an orbiter was no longer needed. Propulsion module was used. Already an orbiter that could be used for communicating with the lander. The propulsion module was a new one that took the lander rover and to space. Okay, so objectives of the mission: demonstration of safe landing. And that itself was a success, as you know. The other objective was roving. What is roving? Something has to come out and move on the surface. Which sounds much easier than it's not like just setting out a toy car. It has to actually unknown sort of like craters. But this was successful. And the rover came out at the point where the lander landed. It was renamed by the Prime Minister. And it moved this much. It also conducted in-situ experiments. That was the objective. Anybody knows what is in-situ? Yeah, I think some of you are about to answer. It's on site. If you're standing somewhere. So that's the difference between an orbiter or something from a distance. Now rover is on the ground. It can move around. It can sample. It can take measurements of the atmosphere. And so there were successful experiments. I'm just going to show you a few successful things that happened. On the left crater is a crater that the Chandrayaan rover encountered. This rover was able to project back this image to the ground station. And the ground station told it, stop, don't go further, fall into this, you won't be able to get out. It's very deep. And it was able to take its communications and change its path, move backwards, retraced its path, which is shown on the right hand side. So quality of communication, sending its camera and how it responded. Here's some other scientific results of importance. The chastity experiment measured the surface and only drilled 8 centimeters. And can you believe it? 8 centimeters of degree drop. So just think of it in your head. If you go to your garden, 8 centimeters, there'll be no change. In the moon, it found 60 temperatures, centimeter drop, which means probably the insulation of the soil is very good. Probably there is indeed a chance of finding icy water deep down. Okay, so here's another experiment that had a great result. ILSA, which had a lunar seismic activity. Anybody knows what is seismic? What does the word seismic stand for? Yeah. Right, that's seismic is waves, earthquakes, or vibrations, or tremors. What did it find? It correctly recorded. This is an image. Correctly recorded the vibration of the rover. On this finger was on the rover, and it found something additional. It found a wave. So it actually recorded a moon. So for the first time, it was recorded in 1970. So this showed that maybe the moon still has some activity which might be volcanic related. Okay, so here's another laser-induced breakdown spectroscopy. Again, you might have heard about these words. What did this do? It actually did what I'm doing right now, which is it shot a laser into the ground. It shot a laser, and that evaporated atmosphere above it. You could take measurements. Spectrum means the wavelength. These lines indicate elements like sulfur, which do indicate possible signs of habitability or life. So congratulations to I showed you some of the scientific results. And obviously Chandrayaan 3 was a great success. And now it's celebrated as National Space Day. So that's not all. There are so many things happening right now. I'll just touch upon a few of them. NISAR, Chandrayaan 4. I'm going to talk a little bit about Gaganyaan and Bharat Station. So let's see. Axiom 4 mission. Who knows why this was so much of a favorite Indian media? Why was it important for India? Can anybody stand up? Can anybody say this? I don't have it here. I don't have it here. Anyone say that line? Yeah.
Because
Right, that's right. This mission brought back Indian astronaut, not only Indian astronaut, but an astronaut Hungary and from Poland. First 40 years, all went back to return to space. The first astronaut in space was of course Rakesh Sharma. Himanshu Shukla became the first astronaut to ISS. Now does anybody know? Does ISS really have zero gravity? Is that right? If you think it has zero gravity, raise your hands. Right, so it does achieve zero gravity. But there is still gravity working on the ISS. How is it staying in orbit? But the reason it achieves zero gravity is like if you stand in an elevator and somebody snaps the wires, like you see, you go crashing down, or you're in a roller coaster and you achieve weightlessness because you're traveling at the same speed as the object you're in. Additionally, ISS or other satellites have achieved an orbit and that is taking them against gravity. So based on this, it appears to be that's the effect inside the ISS. So many experiments could be conducted in the ISS. So we have a picture of the astronauts who joined astronauts who joined were already there, and the experiments done. Many experiments were to see the effects on different signs without the effects of gravity. For example, you might have seen pictures of water drops that float around. Water behave differently without gravity. The way the condensation, the evaporate, everything changes. This is an experiment, which was an Indian experiment, testing the growth of like moong dal, lentils, to see how making seeds. How they can go in because eventually if astronauts go to space, they will need to grow their own crops. The NISAR mission. Has anybody heard of the NISAR mission? Okay, so NISAR mission just happened recently. It's a NASA and ISRO. And why is it important? Just the one line I said first is important. It means NASA, now ISRO, and now cellular technology, ISRO, space. So this is a radar-based experiment. What does radar work? And how does it work? Anybody knows? Okay, what it does is same way I put the laser beam, radar shines a light, comes back to the vehicle. Through that you can tell a lot about the location, how much time it took, based on that you can map the elevation. This NISAR mapped the elevation 4 to 6 times a month for the same location. What does that mean? It means it's looking repeatedly location of the Science Museum, for example. And if things change, ground changes, you can tell you can tell disturbance, you can tell natural hazard. Supposedly earthquakes, you can tell the ground is changing. This might be able to help predict earthquakes or tsunamis in advance. So here's an image that kind of shows that. This is an animation. I could animation. What moves a little bit. So areas are observed multiple times. Now a big mission which is coming out, which is Gaganyaan mission. India's first crewed mission. India has not taken astronauts to space. So what will this mission do? Take three members to an orbit of 4 for 3 days, and bring them back. Now, it's not easy to send humans to space. You have to worry about what will happen to the launch vehicle. Has to be human rated, has to have a life support system, and a crew emergency escape system. Now, all of these have been tested one by one, and they have already started. And 2028 is the projected date. Of course, it might slip. Now, I don't know if you know what Shubhanshu went on Axiom. He's already a selected astronaut for the Gaganyaan, which means he's already trained, and he also knows how the ISS works. So that's a big advantage. Chandrayaan mission will bring back soil samples to Earth. So this is technologically very challenging because not only does it have the soil regolith of the moon, but it has to send something back up. It has to launch something from the moon, which has to connect the orbiting module and then come back to Earth. So Chandrayaan 4 is technologically very difficult, and ISRO has already tested docking part of this objective. There's also Chandrayaan 5 in the works. Anybody knows what that will do? That's not yet in the news. It's called the Lupex mission, Lunar Polar Explorer. It's a collaboration with Japan Space Agency, and that will actually take the vehicle much closer South Pole than Chandrayaan 3 had reached. Now Bharatiya Antariksha Station, Space Station, that's also planned. ISRO has given the go-ahead. It will again be 400 kilometers above the Earth, where astronauts can for 3 to 6 months. The planned launch is in 2035. So I've told you so many things. I'll tell you this is going to be the last thing I say about space. How we are going ahead. Now as NASA, ESA, all in the game now. All moving ahead. And it's no longer enough with the old technology. So we have to go for new technologies. So this is part of what discoveries are. All of you listen carefully because your future lies in 10 years. Right. So reusable launch vehicles. Imagine driving a car. What happens if you buy a new car and just give it up? We reuse the car for a long time. 15 years. Reusable launch vehicles changes the budget totally because it makes it more affordable for smaller companies, private companies to enter, this space exploration. And I just want to point out that ISRO has started this technology. They have done the first testing of these kind of prototypes. But yes, SpaceX has been the one to have started reusable rocket technology. As you may have seen, there are very interesting of SpaceX rockets coming back. Artificial intelligence, now you know already in the world around. How is it used in space? It helps guide, like I showed you, guide autonomous missions. It helps data coming in now. It helps in analysis of data. It's like a co-pilot. It can help plan a mission, make it as the mission is ongoing. Okay, here's another new technology. Advanced telescopes. You already know telescopes are advancing. Hubble to James Space Telescope. There's another telescope in the world. Roman Space Telescope. Even more. Because you want to see even further. You want these telescopes to venture even further. How do we do that? It needs a lot of power, strong communication systems. So all this is being planned. 3D printing. All of you are doing 3D printing. It's going to be really needed. Tools and space. Suppose you have a planning habitat. Take prefabricated material to space and build a moon habitat. Very difficult. But if you have the material and create it and print it in space, or something stops working in space, printed in that again makes it possible for space habitats. Now, right now we have propulsion, solid propulsion. Eventually we have propulsion further out, going further out, faster. ISRO, this is the word ISRO, in situ resource utilization. So it's going to be very important. If you go to Mars, or the moon, to carry oxygen. How many can you carry? Right? So you will have oxygen from the soil. You have Mars carbon dioxide, which is not the best thing. Not what we want. It's not what we want. Carbon dioxide has oxygen component as a component. So it can be pulled out. These experiments have already happened. So in situ resource utilization, maybe utilize the soil to build, underground habitats. So this is going to be very important. So space industry has expanded a lot, and as you can see, it's always in the news. It's expanding. It's a huge industry internationally. Even in India, it has expanded a lot. And now ISRO has started supporting private startups and private companies that are going to be supplying rocket parts, supplying upstream like data analysis. So this is really space industry is set to grow. So which of you want a career in space? Let's see a raise of hands. And then I'll tell you. Great. Some of you said yes. Maybe at the end of next 3 slides, more of you might say yes. So these are some nodes. Space careers. Who knows of some space careers? Yeah.
Robotic engineering.
Yeah. And lastly, we can say astronomer. They're not the same thing. People ask me, am I an astronaut? Can somebody say yes or no? I'm not an astronaut. I'm not going to space. That's satellite technicians, mission control. However, there are many careers now that you don't know about. For example, space miners is something that will come into. What is a space miner? We might need to resources from asteroids. Maybe it can be done autonomously, space vehicles. Maybe someday we need space miners. Maybe we need space debris. I'll tell you more about that. Space tourism is on the maybe we need space tourism managers. All the teachers sitting here. That makes life difficult for you. You train students to be aerospace engineer. How do you train them for a career that doesn't exist? It means you have to know about emerging technologies. Okay, so I know some of you like physics. Let's say raise up hand for who likes physics. Okay, a lot of you have teachers sitting next to you, so you don't really say no. Who is interested in biology though? Okay, I say no. How about math? Okay, how about design? Okay, I'm glad to see because normally for a scientific talk, raise their hand for design. How about arts? Okay. And how about medical? Okay, and last one I'll ask you, how about law? Okay, great. So many of you, and how many of you, food industry. Okay, the good news is space is interdisciplinary. There's a space for all. I'm just giving you two examples. All those who raise their hands for lawyers, you can become lawyers. How? What's a space lawyer? As you go into space, you need. Okay, guys, I know you're excited about this. Let me tell you. What's the role of space lawyers? You know, when I was on the TV station when three landed, and they asked me, ma'am, we own this area now, Shiv Shakti, and why we did plant a plant, but of course we don't own it. So who owns it? When you reach the moon or Mars, or orbit a planet, do you order the rules? What are the rules governing space? Space travel, space missions. Can you know of airspace rules? But do you know any satellite go around any country? So we have space lawyers now. Do govern space laws. You have to know about space policies. And the United Nations Outer Space Affairs is the organization going through creating space policies. Now some of you said yes that you like food. You can still be a space food engineer. Because food is not the same as here on Earth. You can see pictures of chasing after food particles. So how do you actually give astronauts food to astronauts? They have to be specially packaged. They have to be hydrated. And also they have to be nourishing because conditions zero gravity are different. And also can crops be grown in space. So these are all kind of careers that you can think about. Space debris. As I mentioned, what is space debris? There's so many satellites now because the deployment of satellites. So many satellites. They're deep. There's so many small parts. It's like a space traffic jam. How do you deal with it? Scientists who are tracking this. It's called debris. Or jump, try to figure out, can you bring it back to the Earth's atmosphere? It might burn up. So they have robots, they have lasers that are trying to destroy. This is all new technology. And someday we might re-engineer actually work actively. Okay, so these are emerging space. They also include space tourism, like I said, and multiple careers. Sitting here right now, are space educators, communicators. So if you like talking about space, that can be a role. So how do you prepare for a STEM career? Investigate, you ask a lot of questions, you invent about things and try to see how you tinker and you thinker and create. Do you have to be a certain type? When I was growing up, I don't think I faced it now. When I was growing up, people or physics were treated as nerds, right? You were always not in the fashionable section society. But now that has changed. Certain time, anytime you can be interested in design. There is astronaut suit design. There is human user interface that is needed for space. So you can have all kinds of space careers. Not just rocket scientists, astronauts. However, if you want to go into the mainstream, you have to stick to physics, engineering technologies, computing, and so on. So with that, there are no limits. Now man has gone and there are footprints on the moon. So there are no limits. And I encourage all of you keep on being curious, and keep asking questions.
Amazing lecture, and ma'am, all are bound, spellbound, and I think every word she spoke आपके अंदर तक गया। एक बार फिर से जोड़ो। बहुत सारे कैरियर अपॉर्चुनिटीज बताए हैं फ्यूचर में लगता है डायरेक्टर साहब प्लीज ओके may I now जैसे कि मैम ने बोला to ask questions. Who is going to ask the first question? Mike Milo. Yes.
Good question. Life on Mars is possible. And so now, how do scientists even find life? We see aliens, right? But how do we define life based on Earth parameters, which is breathing oxygen, use of water. Based on this, life is ongoing. We are looking for planets that have possibility of water and the right temperature. Earth is called as Goldilocks zone. That's just the exact right temperature for water and for humanity to survive. So Mars is, but there might be in microbial and there are missions not only to Mars, also some icy moons like Europe. They are looking possible signs. And originally life was in the organic molecules. The other thing that is being looked at, emission of methane, for example, and that is what is being looked at. We don't know exactly, but so far the rovers on Mars have only found some possible signs. Maybe past water, but not currently.
Yes, that's good.
How is the discovery of Mars or next big thing?
Will you speak louder?
How is the discovery of
Silent please.
How is the discovery of Mars the next big thing?
So that is a good question. Very good question. Okay, so I'm glad that you listen carefully to my talk. Yes, so there was a sign of that I showed that you noticed it, and sulfur is a sign of volcanic eruptions. Okay, and volcanic, it has been found that in organic molecules near volcanic eruptions are the first places to create life, because it was a mix of organic material as well as lightning as well as and so this is a sign of volcanic, and life could be volcanic, there is volcanic, which could be a sign of life. Good question.
Yes, next please. Maybe about your career, yes.
repeat your question on the mic.
How exactly are scientists using artificial intelligence in science exploration?
Okay, so again, very good question, and again, that means you listen carefully. So artificial intelligence, all of you know now, all aware of AI. We don't want to take over the world. However, AI can be very useful assistant. Now, I talked about so many like JWS, like nice. Now they're bringing in so much data. Lot of our computer programs that so far are not sufficient. Handle this data and find patterns. However, AI can do that. So one way is to look through a lot of data, find patterns and find solutions, and that is being done by AI. Progress more as time goes by. Also AI is being robotics and space robotics. So rovers or missions that will be enabled with AI decisions on the spot. Like if you're going to be landing wrong spot, AI will guide you. Same with rovers, they're all doing AI with autonomous software, whatever we're equipping them with, can gain further intelligence to make decisions as you go. And not just land, but also as it's going out, we need to make decisions. So that will help replace the role humans to some extent because they will be able to make informed decisions.
Yes.
Can robots replace astronauts?
Can rovers be astronauts? Yes. Yeah, again a very good question. Rovers, yes. I did tell you this point. Gaganyaan, one of the next missions that are testing is going to take a robot to space. So there's a human robot that is going to go into space Indians can go. So why are they going? Because they can absorb information, they can make informed decisions. They can withstand the danger. They can withstand the danger. You don't have to send animals anymore. They can absorb all the parameters. Sitting here on Earth, we can't tell what is the temperature, what is the pressure, atmosphere, how it affects the humans. But if you send robots, robots, then you can take those measurements, you can send the data back, and you can without causing danger to humans.
More questions, please. Today we have a very exciting lecture, I think.
How should we quantum the role of quantum computing and research and exploration?
So again, that's a very good question. Very good. And I didn't even mention this. So kudos to you for keeping up with this technology. So quantum technology. How is that important? Space research. Some of you might be knowing about quantum technology from different points of view. Quantum technology is something even ISRO is getting into. How? Because quantum key protects, it's useful for data protection, data security. No, which data the most? Space data. You don't want somebody to hack into our space and tell him to go somewhere else. So space data stream has to be protected. And quantum technology is being looked into. How is quantum technology different from regular computing? One example of how quantum technology is used. Regular technology, there are two states. Zero, which is 0, 1. And it's binary. Okay, it's binary. Quantum technology is multiple states. It's called qubits. Instead of 0 and 1, 0 and multiple states makes it hard to hack a system. And even if we try to hack, instant notification. So this is very important technology for security, data security.
Thank you very much. Thank you very much. Now I think we are running out of time also. Now very good question sessions with the madam. Please clap for
And as someone on stage, I would like to tell you that I'm so happy to see all of you excited about this. You follow me and ask questions and I'm with STEM in space. We do workshops, and I also encourage citizen science personally. So if any of you are interested, please communicate with me.
Before starting that, I request Before I formally read some words on the vote of thanks. I request to all the students and teachers that you are on the social platforms, kindly national science on X, Facebook, Instagram. Do check our websites because we will have a lot of information, a lot of experiment on site, which you can do and which you can will guide you. So the recording of this lecture will be available on our YouTube channel, which is NSC official. After editing will be available after a few days. So with that, first of all, thank Mitra for spending this her valuable time and very concurring subject of space technology for the missions. I thank all the schools who have attended the lectures of the day and auditoriums for we have strength. And in fact we have to say some of this because the capacity is already over. I thank the NCT and the other sections for this particular lecture. And in last time the director of the National Science and for organize this particular. Now with these words, the formal thanks is over. All are now invited galleries of the National Science Center. Explore them on human biology, on fun science and technology. And Sardar Patel is still working. Exploring is available. Now for the refreshments, Dinesh Patel last week. All the teachers all the lectures respect on the canteen. A new window for you to peep into the space. So now peep into the space and see what is the opportunity. Thank you very much.